Okay, so today's topic is Sandmeyer's reaction, and from today onwards, we will be going through name reactions. The first name reaction is Sandmeyer reaction. I've drawn the general reaction here, so let's go into depth of it and see the reaction mechanism as well. So first, the Sandmeyer's reaction is formation of aryl halide from diazonium salt. So I have drawn an example here. So what is this is benzene diazonium chloride, in which CuCl is working as an catalyst. There is formation of chlorobenzene and liberation of nitrogen gas. So what happens is the Sandmeyer reaction is a nucleophilic aromatic substitution. So what will happen is it is somewhat like this. So we will go through the mechanism now and we will see what is happening. So first I'll draw the basic ring that we all know, that is benzene diazonium chloride. I'm taking chloride as an example, but you can go and take iodide, bromide as you wish, or whatever the questions that may come from it you can take. So it is supported by the detection of biaryl byproducts. There is substitution of the aromatic diazo group with the electron transfer mechanism, which is catalyzed by the CuCl. So what will happen is there is CuCl, and what will happen, this is the one. Okay, so the copper species will be there, and there is, and this is catalyzed by copper species, and it forms aryl radical with loss of nitrogen, and after that the substituted arene is possible to form by direct transfer of chlorine, bromine, or whatever that you take in place of chlorine. So I'll go through the reaction now, like the mechanism of the reaction. So this is Cu1Cl. What will happen now is N1N. So at very first there is single electron transfer, the transfer of one electron from Cu copper to one of the nitrogen. This has the negative charge, this has the positive charge. Okay, so single electron transfer from copper to nitrogen. What will happen, we will be seeing here. So when the transfer of electron takes place, it will be converted to electron 2 species, and there is Cl joined to it. When the one electron species is transferred, it will be somewhat like this, and the electron will give the bond here, will form the bond. This bond will be coming here, and this bond transferred here. So this is the basic thing will happen, like due to one of the electron transferred from here to the nitrogen here, the electron will form a bond, the bond will be break, and this bond will give out a electron. Okay, so what will be the second thing that will be formed is, first the nitrogen gas will be released, that is the intermediate product. What will happen to the chlorine is, there is a chlorine here also and here also. So the second chlorine, which was attached to the nitrogen here, will get added to the copper. So Cu Cl, and this will be 3 here. This will be formed because one electron is given here, so there is electron deficient, so one electron will be taken from the chlorine group, hence this will be formed, and the benzene will be deficient 2 from one electron. One electron deficient, so it took up the chlorine. What will happen is there will be formation of benzene and copper bond, a bond between benzene and the copper. How it will look like is when this comes here and this will react with it, there is Cu, Cl, Cl, and this will be 3 now. Sorry, this is 2 only. So this will be 2 because 2 bonds, nothing, 3 bonds, hence this will be benzene. So after this there is reductive elimination from Cu3, or you can say there is direct atom transfer. So what happens is this Cl will be transferred here and the bond will be transferred here, hence we'll draw this minus Cu Cl, this will be 1 again, so minus 2 dots because of the electron, and this is Cl, this is what will be formed, chlorobenzene, and this is the mechanism. So previously what this had is CuCl was connected to the benzene group, CuCl2 was joined to the benzene group because benzene was electron deficient and copper was electron deficient too, so it took up chlorine with it to stabilize its bond. When copper bond binds with benzene, it has one extra electron to give away. So what it will do is chlorine group will be transferred to the benzene and the bond will be transferred here. So bond transfer will give the extra electron back to the carbon, and benzene was electron rich here, Cu was electron deficient here. Nitrogen gained an electron because of the electron transfer, single electron transfer from the copper. Electron got to the nitrogen, electron formed a bond, the bond formed and the bond break because of the formation of the bond. This bond gave an electron to the benzene. Benzene had an extra electron, hence copper conjugated with it, not conjugated, formed a bond with the benzene group to Cl minus Cl, CuCl back to its original species Cu1, formation of chlorobenzene. So this was Sandmeyer's reaction. Thank you for today. Let's meet up tomorrow for another name reaction.